it is called the scalar triple product. What's the name of this thing? It is called the scalar triple product. What does it mean? Suppose that if we have three vectors, how can we define their scalar triple product? That is, one of the operation is the dot product, and the other operation it is the cross product. It is the cross product, and that's how we are going to define this thing. So imagine this thing in the following way. Okay, imagine this thing in the following way. That is, we have so suppose that we have three vectors A, B, and C. These are the three vectors, and the two different types of the products. That is, the one is the dot product, and the other one it is the cross product. The other one is the cross product. So the question is, how do we define this thing? How do we define this thing? So here we have this formula. This formula says that A dot B cross C, this is called the scalar triple product. It is defined in this way. In the first row, we write the components of the vector A, that is A1, A2, A3. In the second, we write the components of the vector B, B1, B2, B3, and then C1, C2, C3, and then we expand this determinant with the method we have discussed in the beginning of this class. Then you can find the scalar triple product of these three vectors. And the next thing is, what is the physical or the geometrical interpretation of this thing? What is the geometrical interpretation of this thing? So if you imagine this thing, so geometrically it will give you the volume of this parallelopiped. Okay, so this is the geometrical interpretation of this scalar triple product. It is the geometrical interpretation. It is the geometrical interpretation of the scalar triple product. So what does this give you? Geometrical. STP means scalar triple product. So we have three vectors A, B, and C. Okay, we have three vectors A, B, and C. So these three vectors together, they form a parallelopiped, and when we find this scalar triple product, it will give us the volume of this parallelopiped. It will give us the volume of this. This is called the parallelopiped. So it is equal to A dot B cross C. So when you find this thing, it will give you the volume. It will give you the volume of this thing. And basically at the end, since we know that the volume is always a positive quantity, so here you have to put the absolute sign. Suppose that in the scalar triple product, the answer can be a negative number. So at the end, you have to take its absolute value. That is, change the negative sign into the positive sign. It will give you the volume of parallelopiped. Let's do an example related to this. We are given three vectors. And we need to find the scalar triple product of them. Okay, use scalar triple product to show that A, B, C are coplanar. First of all, let's find out the scalar triple product of these three vectors, and then I will explain to you what do we mean by this coplanar. Okay, what do we mean by this coplanar? So let's first find A dot B cross C, which is equal to the determinant of 1, 4, 7, 2, minus 1, 4, and 0, minus 9, and 18. 0, minus 9, and 18. Let's expand this thing. You can put a circle here. We have the minus sign. 2 minus 1, 4, 0 minus 9, 18, and it is equal to 1. Let's do this one more time. Minus 18 plus 36 minus 4. Here we get 36 minus 0 minus 7, and then minus 18 minus 0. So this is equal to 18 minus 4. 2 multiplied with 18, and from there you will get plus 7 multiplied with 18. Now if you take 18 outside as a common factor, from here you will get 1 minus 8 plus 7, which is equal to 18. 8 minus 8, which is equal to 0. So it means that these two vectors are